Good morning, sixth period and first period. So while you're missing me today, I want you to watch this video on inverse functions. And basically what an inverse function is a function that reverses another function. Now what does that mean, reverses another function? Well, what it means is the domain and the range are going to switch places. It's as simple as that. So now what was your input now becomes your output. What was your output now becomes your input. So let's look at a couple of examples here. So I'm going to look here at the first one, which is example 1. Now if you look at example 1, what we ultimately have here is we have a mapping, and we've talked about mappings before. That's just basically another way of showing a function's input to output using the x and the y instead of using a table. It's basically a table in a different format. So let's look at our first one, which is f of x. So I've got f of x. This particular function is my regular function, f of x. F of x shows that when x is 0, y is -1. When x is 2, y is 0. When x is 4, y is 1. When x is 6, y is 2. And we've done these 1,000 times. You know how to map and use the x-coordinate as your input to find your y-coordinate, which is your output. So what the heck is an inverse? Well, an inverse function is basically when we switch the domain and range. So the notation for inverse is this right here, f -1 of x. That's not f to the negative first power. That just means inverse. So I write it one more time. This is the notation for the inverse function. That's when the domain and the range from the original function switch places. So now look at this mapping. Instead of 0 being my input and -1 being my output, -1 is now my input and 0 is now my output. Instead of 2 being my input and 0 being my output, now 0 is my input and 2 is my output. Instead of the original function where 4 is my input and 1 is my output, now 1 is my input and 4 is my output. And on the original function, when 6 was my input and 2 was my output, now 2 becomes my input and 6 my output. So you can see the only thing you do to create an inverse function is basically switch the domain and range. So switch your x's and your y's. It's as simple as that. So let's look at another example here, and we'll look at this in terms of a list of points instead of using a table. So I've got this function here, f of x, and it contains the points 1, -3, -2, 3, 5, 1, and 6, 4. So what this is actually telling me is that all of my x-coordinates, or my inputs, are what I'm underlining in blue. Those are all my x's. Those are my inputs. Okay. All of my outputs, or my y-coordinates, are what I'm underlining in brown. Input, output. That's the original function, just your plain old f of x. So let's find the inverse of f of x. And again, the inverse is just indicated with that -1. It doesn't mean to the negative first power. It just means it's an inverse. So let's figure this one out. So since my original has the point of 1, -3, the inverse would be -3, 1. Since the original function had -2 input, 3 output, the inverse is going to have 3 input, -2 output. Since my original function had 5 input, 1 output, 1 is now the input, and that creates an output of 5. And then my last point, when 6 is the input, 4 is the output for the original function. So for the inverse, 4 becomes the input, and 6 becomes the output. So what you're seeing is how you get from a function to its inverse. You basically switch the domain in range.